All right, so moving back to our class data, I'm going to give you one more example of a cumulative frequency distribution. And we're only going to do it for this one question here, which is feelings about math, because if you remember the other questions, the would you rather questions, they don't have variable attributes that can be put in order. So you can't say that killing someone and having nobody know is more or less than killing no one and having everybody think you did. So those are nominal level variables, and you can't find a cumulative frequency distribution for them. So here we're only going to be looking at this one question. And so here we have the categories in order, from how much you love math to how much you hate math. So as you move down that column there, you can think of it as sort of increasing in your hatred of math. So we have our frequencies again, and in the first column, or the first column after the variable names, and then in the next column after that we have cumulative frequencies. So with each of these, you're again looking at the number of people in the class who gave each answer or less. So 4 people said, I love it, oh boy, and they had the least amount of hatreds towards math. Our cumulative frequency for I like it, I guess, is 10. And this means that in rating how much you hate math, they were at I like it or less hatred than that. So I like it or I love it. The cumulative frequency for it's okay is 16. And this means that in the class, 16 people rated their hatred of math at it's okay or less hatred than that, which includes it's okay, I like it, and I love it. Our cumulative frequency for I'm not a fan, but I'll do it if I have to, is 38. So that's 38 people in the class whose hatred of math is at a level of I'm not a fan, but I'll do it if I have to, and less hatred than that. So all those other categories that are above it in the list. And then finally, we have a cumulative frequency of 53 for gouging your eyes out. So everybody in the class was at that level of hatred or less, which makes sense because that's the most hatred towards math that I allowed you to express in my survey question. The cumulative percents show the same thing, just with percent, so I'm not going to go through each one, but if you want, you can double check it on your own time and kind of see how I got those values there. All right, so we're going to move on to one other type of frequency distribution, and it's going to be a type of frequency distribution that allows us to deal with this problem. Here's the frequency distribution for the greatest number of alcoholic drinks that you guys have had in one night. And where somebody gave me a range of like 5 to 6 or 6 to 7, that's where those 0.5s come from. Also, somebody said a couple of handles, so with a little help from Google, I estimated that at about 60 drinks in one night. So here is the number of drinks that you guys have had in one class. Or sorry, in one night. So looking at this, the problem is that we're kind of back to the problem we had in looking at the raw data, which is that we just have a whole lot of numbers. And it's hard to look at this at a glance and get a whole lot of information from it. So it's defeating the purpose of having a frequency distribution. And if you look closely, you can see, yeah, so 7 people have never had any drinks in one night. 2 people have maxed out at 1 drink, 1 person maxed out at 50 drinks. But again, just at a glance, you're not getting a whole lot of information. But with this, it's still interpretable. You can get into an even bigger problem. Wow, this is like a day for talking. You can get into more trouble, though, when you're looking at variables that have even more possible values that they can take on. So this is from a survey that I did several years ago now. And one of the questions was, how many years have you served as a police officer? So it's a survey of police officers. And so this is what the frequency distribution looks like for that. And with this, you're just, again, being bombarded with information, and your frequency distribution isn't that useful as a way of organizing data. And you can imagine even more. So, there are variables that can range from 0 to 1,000 or 0 to 100,000. And you wouldn't want to have a different line in your table for each one of those different values that a variable could take on. So because of that, we're going to turn to something else, which is called a grouped frequency distribution. And what a group frequency distribution does is take those many, many, many numbers you have and just collect them into groups that you can then see the frequency for. So for a group frequency distribution, you can only use variables that are measured at the interval or ratio level of measurement. In other words, you can only use variables that are numerical. If you have a variable that's nominal or ordinal, it's not going to be measured as numbers, and you're not going to be able to do a group frequency distribution. And essentially what a group frequency distribution is that it's a frequency distribution that shows frequencies for ranges of numbers rather than for each individual number. And ranges of numbers would be the reason that you have to use numerical data. So there are steps to creating a group frequency distribution, pretty similar to creating a regular frequency distribution, but the difference is that here you have to decide what range of numbers that you're going to use. And each range of numbers is referred to as a bin. You're not going to be tested on that later, but that's what that means there. So you have to decide what range of numbers you want to look at in creating your group frequency distribution. Then you're going to list each of those out, and you're going to list the number of observations in each bin. And I think the best way to do this is to just show you guys an example, which I'm not going to bother with the document camera for. I'm just going to go to the next slide. So we had this as our class data for the greatest number of alcoholic drinks that you guys have had in one night. And a way that we can present this data instead is to bin those numbers of drinks in groups of 10, so 0 to 9, 10 to 19, 20 to 29, and so on. And so each of these bins represents a range of the number of drinks that somebody might have had in one night. And then we can find the frequency for each of those. So what this tells us is that in the class, 27 people had between 0 and 9 drinks as their maximum number of drinks, in their life. And so at a glance, you're getting a lot more information from a table like this than you are from a table that has each individual number of drinks listed out. And so you can see here that the most common value is, the most common set of values is 0 to 9. 52% of the class has maxed out at between 0 and 9 drinks. The next most common set of values would be 10 to 19, and you can see 37% of the class has maxed out at 10 to 19 drinks. And as you get to sort of more and more impressive amounts of drinking, you get to a smaller number of people in that category. The cumulative percent also tells you something similar there. And so with our cumulative percent of 89% for 10 to 19 drinks, that means that 89% of the class has maxed out at 19 drinks or less. So same interpretation as in a regular frequency distribution. One other quick thing to note here is that my cumulative frequency ends up at 101%, and this is because of rounding. And so the total frequency there would also end up at 101%. Sorry, the total relative frequency would also end up at 101%. So in this class, there are going to be several occasions where I'm going to ask you guys to add things up and say that it should reach some number. Anytime you round, it means that you might end up with a little bit less or a little bit more, and that's okay. So if you're aiming for 100% and you hit 101% or 99%, and you were rounding the values before you added them, it doesn't mean you did it wrong. It is probably just because you were rounding the values. So just a quick note there. All right, so that was our last type of frequency distribution that we're going to talk about today. And we have a couple other topics in this lecture to talk about how to organize data. The next one is going to be a quick one, but it's one that can also be incorporated into frequency distribution, so I talk about it here. And that topic is rates. So a rate is something that can be calculated for any numerical variable, or in other words, variables that are measured at the interval or ratio levels of measurement. And what rates do is they standardize numbers by adjusting for population size. So in that way, they're similar to a relative frequency. And you probably encountered rates before, so you hear things about, say, the crime rate all the time. And what that is that's the number of times something has happened relative to the number of people you have in your population. And so there's a big difference between talking about the total number of homicides and the number of homicides between 10,000 people. When you're comparing among cities, say, that have different numbers of people. And so I'm going to talk about the steps here, and then I'm going to go back over to the document camera one last time to go through an example of how to calculate a rate and how to interpret a rate that you calculate. And so the steps in calculating a rate, the first one is going to be to divide the total number of cases or observations you have by the total population in which those cases could have occurred. And then you're going to multiply by some base number, which is a number chosen by you or your professor or whoever's deciding how to make up the rate. That's telling you per X number of people, how many times did this thing occur. So in the example above the steps, if you are looking at homicides per 10,000 people, your base rate is going to be 10,000 people. If you were looking at homicides per 100,000 people, your base rate would be 100,000 people. So with that in mind, I'm now going to go through and I'm going to calculate some rates and talk a little bit about how to interpret them.